I'm Anil Kumar. Welcome to my series on quadratic relations. Here are a few questions which will help you for your test preparation on quadratic relations. I have taken variety of questions here to give you a good practice. Question number 1 is the graph of y equals to minus 2 times x plus 5 whole square plus 8 is translated so that its new zeros are minus 3 and 1. Determine the translation that was applied to the original graph. The x-intercepts of a parabola are minus 3 and 5. The parabola has a y-intercept of 15. Peter said that an equation for the parabola is y equals to minus x squared plus 2x plus 15, and that the coordinates of the vertex are 1, 16. Do you agree or disagree? Justify your opinion. Question 3. The vertex of the parabola 2x squared plus bx plus c is at 1 minus 5. Find possible value of b and c. Question 4 here is express each relation in vertex form using partial factoring. A. Y equals to x squared minus 4x minus 5, and b is y equals to minus 2x squared plus 12x plus 8. I'd like you to pause the video, take it as a test, solve the questions, and then look into my suggestions. Now let's see how to solve these questions. The very first question here is that the graph of y equals to minus 2 times x plus 5 whole square plus 8 is given to us. So we are saying that the equation is y equals to minus 2 x plus 5 whole square. After translation, zeros are at minus 3 and 1, and we need to find the translation, right? So that is the equation, correct? So we are given this equation y equals to minus 2 x plus 5 whole square plus 8, and after it is translated, then the zeros are given at minus 3 and 1. So this is translated. Once it is translated, then we have zeros at x equals to minus 3 and 1, correct? We need to find the translation. That's the whole idea. So what we should do here is to first find the zeros and then compare. So let's find zeros of this particular equation. So how do you find zero from vertex form? So the step here is to find zeros of the given equation. So 0 means y equals to 0. So we'll substitute 0 for y and then solve for x. Bringing 8 to the left side, we get minus 8 equals to minus 2 times x plus 5 whole square. Dividing by minus 2, we get x plus 5 whole square equals to minus 8 divided by minus 2, which is equal to plus 4. Now here is a very important step. When you square root, you should take both positive and negative, correct? So let's square root and find. So we have x plus 5 equals to plus minus square root of 4, which is equal to plus minus 2. So what did we do here? We square root both sides. So what you should remember to put plus and minus, right? Since square of minus 2 is also 4, right? So don't miss the other solution. So from here we get the value of x as equals to minus 5 plus minus 2. So that gives you two zeros. One will be at minus 5 plus 2. The other one will be at minus 5 minus 2. So this is at minus 3 and the other one is at minus 7. But what are we given? We are given that after translation, the zeros are at minus 3 and 1. Now how do we get these values? we are given that the zeros are at minus 3 and 1. Now here we get zeros at minus 3 and minus 7. So what kind of translation can produce the zeros at minus 3 and 1? Well, we could add 4, right? So if I add 4 to these values, in that case, the new values could be, that will give us 1 for us, and this is going to give us minus 3. Does it make sense to you? So that means that the graph has been translated 4 units right. Perfect. So here we can say that the original zeros are at minus 3 and minus 7. So what do you need to do? You need to translate 4 units right to get new zeros at the given value of minus 3 and 1. Does it make sense? So the answer for this is determine translation that was applied to the original graph. So the translation here is 4 units right. So I hope you have understood the concept. So that is how you're going to solve this kind of a question. Let's move on to the next question now. Question number 2 here is, the x-intercepts of a parabola are minus 3 and 5. The parabola has a y-intercept of 15. Peter said that an equation for the parabola is y equals to minus x squared plus 2x plus 15, and that the coordinates of the vertex are 1 and 16. Do you agree or disagree? Justify your opinion. Now in such questions, sometimes students will do a mistake, and that is they will begin with Peter's equation, verify that the vertex is 116, and conclude that this equation is correct. They also can see that y-intercept of 15 is a correct value. Perfect. And that will be a wrong answer. Perfect. So that's a word of caution. Don't do that. What should you be doing? What we should do here is that we are given x-intercepts of the parabola are given to us, y-intercept is given, right? So the question basically is to find equation where we know x-intercepts are at minus 3 and 5 and y-intercept is at 15, correct? So that is the whole idea. So how do you find equation when you are given x-intercepts? We are going to use the factored form, correct? So we could write this equation as y equals to a times x minus 3 becomes plus 3 here, right? So first 0, the second 0 is at minus 5. So that gives you the equation in factored form. And now we know that the point 15 y-intercept, that is 0 and 15, is on the parabola. So we can substitute 15 for y and 0 for x. So we get this value of a from the second condition, right? So which is 15 equals to a times minus 15, and that gives you the value of a as minus 1. So once you get the value of a as minus 1, you can substitute here and you get your equation as y equals to minus x plus 3 times x minus 5. So this is the equation which you should get. Once you get this equation, then you have to expand and write in standard form. Perfect. So let's expand and write this in standard form. So y equals to minus, let us do x squared minus 5x plus 3x minus 15. So that gives you minus of x squared minus 5x plus 3x is minus 2x minus 15. And when you open the bracket, you get minus x squared plus 2x plus 15, right? So you get exactly the same equation, minus x squared plus 2x plus 15. And that is how you're going to verify that this equation is correct, right? So we get equation is correct. Now, you need to also verify whether the point 116 is the vertex or not, correct? Now, to find vertex from these x-intercepts, you could add and divide by 2, or you can do minus b by 2a, right? So either way, we can know x's for this particular equation is at center of the zeros, correct? So we can add them, divide by 2, so we get 2 over 2 as 1. And if I substitute 1 here, what do you get the value of y? So 1 square plus 2 times 1 plus 15, and that gives you minus 1 plus 2 plus 15, and that is indeed 16, and therefore the vertex is correct, and we can say that what Peter's equation is correct. So we agree, right? Do you agree or not? So yes, we agree. So the answer will be we agree that the equation is correct and vertex is 116. Does it make sense to you? So you need to provide complete explanation, right? So don't do half the work by starting from the equation and verifying that the vertex is correct, right? You have to do the first part also, which includes finding the equation. So I hope this part is absolutely clear, since this could be a part of a communication question where you might lose marks for not doing the first part. I hope it makes sense. Let's move on and take the next question now. Here is question number 3. The vertex of the parabola 2x squared plus bx plus c is at 1 minus 5. Find the possible value of b and c. Now in this equation, you should actually get the equation from the vertex form. So we could write, we know that the vertex is at 1 minus 5, and we also know here that a value is given to us as 2. Now whether it is a standard form or the vertex form, a value remains same, right? So using that, we could say that the equation will be y equals to 2 times x minus 1 whole square minus 5. Now we can expand this, right? So once you expand this, you get x squared minus 2x plus 1, that is expansion of x minus 1 whole square minus 5. That is 2 times, I should have opened, so let me write down here, as equal to 2x squared minus 4x plus 2 minus 5, and that gives you 2x squared minus 4x, and that gives you minus 3. So once you get this equation, then you can compare with 2x squared plus bx plus c. And comparing, you can easily say that b equals to minus 4 and c is equal to minus 3. Okay? So that becomes your answer. So that is how you're going to solve this particular question. Correct? So probably this is the easiest way to solve this equation. Now let's look into the last example here. Purposely I've taken this example since many students do not use partial factoring method so effectively as they should be using. So the question here is, express each relation in vertex form using partial factoring. Normally you do completing these squares. So we'll again review how to partial factor and write the equation in the vertex form. Correct? So we are given two equations here. In one, I have taken leading coefficient as 1. The other one has minus 2 as the leading coefficient. So let's do one by one. So we have y equals to x squared minus 4x minus 5. Partial factoring is that we are going to only factor the first two terms. That helps us to find a point where the y value is same. So axis of symmetry can be easily calculated. Taking x as common here, we get x minus 4 minus 5 here. Now that gives you an idea that at x equals to 0 and at x equals to 4, y is equal to minus 5. So that is kind of point, the midway between them could give you the axis, right? So there are two values of x for which we have same y value. So from here we get the axis of symmetry. So axis of symmetry is midway, which is 0 plus 4 divided by 2, and that gives you 2 as the axis of symmetry. Since 2 is on the axis of symmetry, placing 2 in our equation will give us the vertex, right? So from here we can find the vertex. To find vertex, I'll substitute 2 in the equation. So I get y equals to 2 times 2 minus 4 minus 5. And that gives you 2 times minus 2 minus 5, which is minus 4 minus 5 as minus 9. So we get our vertex as minus 9. So at 2, right? So the basic coordinates for the vertex are 2 and minus 9. Perfect. So that gives you the equation in the vertex form, which is y equals to a value is 1 here, it remains 1. It is same in both standard and any other form. Okay, and we get x minus 2 whole square minus 9 as the equation in vertex form. Are the steps clear to you? Perfect. So that is how you get your vertex form using partial factoring. And you can see it was a much simpler calculation than you normally do in completing the squares. Let's follow this method and do the next one. So here we have a value of minus 2. So I'll take minus 2x as a common factor, getting x. Since minus 2 is there, we'll divide 12 by minus 2, getting minus 6 plus 8. As you can see, again, the zeros are at x equals to 0 and x equals to 6 gives you y equals to plus 8. Same y value for 2x values. So that tells you that the axis will be at x equals to 0 plus 6 divided by 2, which is 3. Now to find the vertex, we'll substitute 3 in the equation, right? So y equals to minus 2 times 3 times 3 minus 6 plus 8. So that gives you minus, this is minus 6 times minus 3 plus 8, right? So what we have here is that we have substituted 3 here. So when I substitute 3 here, minus 2 times 3 is minus 6 and 3 minus 6 is minus 3. So when you multiply, you get minus 18 plus 8. Sorry, plus 18 plus 8, which is 8 and 8 is 16, and we get 26 as the y value. Correct? Since we get the vertex now at x equals to 3 and y equals to 26, we could write the vertex form of the equation as y equals to minus 2 is the a value, right? So minus 2 times x, 3 is your vertex, minus 3. We'll write minus 3 here, whole square, right, which makes it 0, plus 26, right? So that is how you get the vertex form by using partial factoring. So this is a very effective method. For many minimum maximum optimization questions, you could use partial factoring rather than completing squares to find answers. I hope that helps. Feel free to write a comment, share your views, and if you really got help for your test, it'll be really great. Thanks a lot for my... So I hope these set of 4 questions, I hope this set of 4 questions help you to prepare for your own test and get a better. So I hope this set of questions help you to understand quadratic relations better. Feel free to write your comments and share your views. Share my videos with your friends. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.